Have you ever dropped something? A pencil, a book, or a slice of toast? It always falls to the ground. That's gravity at work. Gravity is an invisible force that pulls everything toward everything else. It's why we stay on Earth, and why Earth orbits the Sun. Everything with mass has gravity. The more mass, the stronger the pull. The Earth's gravity is much stronger than ours, so we stick to the ground. The Sun, with even more mass, keeps all the planets in orbit. Without the Sun's gravity, Earth would drift off into space. The Moon orbits Earth for the same reason. Gravity keeps it circling us, creating tides and lighting up our night sky. Gravity shapes the universe, from falling apples to the birth of stars and the structure of galaxies. It's the silent force behind the cosmic dance of planets and stars. Every time you drop something, you're seeing gravity in action. It's not just a rule for Earth. Gravity works everywhere, all the time. It pulls together clouds of gas to form stars. It keeps galaxies spinning and interacting across the universe. From a ball falling to the ground to the grand structure of the cosmos, gravity is in charge. Understanding gravity is one of science's greatest adventures. It's a big deal. Gravity shapes everything we know. Of course, gravity is real. You feel it every day. But science is about asking questions, not just accepting what we see. The real question is, what exactly is gravity? For centuries, people just accepted that things fall, but great thinkers wanted to know why. In science, a theory isn't just a guess. It's a well-tested explanation built on evidence. The theory of gravity means we have a powerful explanation for how gravity works, not that we doubt its existence. Our understanding of gravity has changed over time. Newton's ideas worked for centuries, but Einstein later offered a new perspective. Science is a journey, always refining and improving our explanations. When people question gravity, they're often really asking about the details of how it works, not whether things fall. Science works by observing, modeling, testing, and updating our understanding. Newton's law explained gravity for centuries, but Einstein's theory made it even better. The process of questioning and testing is what drives science forward. So, gravity is real, but our understanding of it keeps evolving. That's the beauty of science. It's always open to new discoveries. The journey to understand gravity is far from over. Let's go back to the 17th century and meet Sir Isaac Newton. Inspired by a falling apple, Newton wondered if the same force pulling apples down also kept the moon in orbit. He proposed, gravity is a universal force, acting everywhere in the universe. Newton's law of universal gravitation says, the strength of gravity depends on mass and distance. More mass means stronger gravity. More distance means weaker gravity. This law united the heavens and Earth under one rule. Gravity pulls apples down and keeps planets in orbit. Before Newton, people thought different rules applied to the sky and the ground. Newton showed it's all the same force, everywhere. It was a giant leap for science. Imagine throwing a baseball from a tall mountain. Gravity pulls it down, but if you throw it fast enough, it keeps missing the ground. This is an orbit. The moon is constantly falling toward Earth, but its sideways speed keeps it circling us. Satellites work the same way. They're always falling, but never landing. Newton's law explains both the apple falling and the moon's orbit. It's the same force, just different speeds and distances. For over 2 centuries, Newton's law let us predict planets' motions and even discover new ones. It gave us the keys to the solar system. The beauty of Newton's idea is its simplicity. One rule for apples, moons, and planets. Orbits are just objects falling around each other thanks to gravity. This insight changed how we see the universe. Newton's law was the foundation for centuries of discovery. Gravity connects everything, from apples to the cosmos. Newton's gravity worked for centuries, but tiny errors, like Mercury's orbit, hinted at something deeper. Enter Albert Einstein, who reimagined gravity in the early 20th century. Einstein said space and time are woven together into a four-dimensional fabric space-time. Mass and energy bend this fabric, creating curves. Gravity isn't a force pulling objects, it's the result of objects following curved paths in space-time. Imagine rolling a marble on a flat sheet. It goes straight. Bend the sheet, and the marble's path curves. The sun's mass creates a huge dent in space-time, and Earth rolls along that curve, its orbit. Gravity, in Einstein's view, is the shape of space itself. This was a radical shift from Newton's force at a distance. Einstein's theory explained things Newton's couldn't, like Mercury's orbit. It also predicted new phenomena, like black holes and gravitational waves. General relativity replaced the pull of gravity with the curve of space-time. It changed our understanding of the universe forever. To picture Einstein's idea, imagine a trampoline as space-time. Roll a marble across the flat trampoline. It moves straight, like an empty space. Place a heavy bowling ball in the center. It creates a dip, curving the surface. Now roll the marble near the bowling ball. It curves around as if pulled, but it's just following the curved surface. Massive objects like the sun warp space-time, and planets follow those curves. Even light bends when it passes near massive objects. During a solar eclipse, scientists saw starlight bend around the sun, proof of Einstein's theory. Gravity isn't a pull, it's the shape of space itself. The trampoline model helps us see how mass shapes the universe. This simple analogy captures the essence of general relativity. The universe is a dynamic, curved fabric, shaped by everything in it. Newton saw gravity as a force. Einstein saw it as curved space-time. Which is right? Both, depending on the situation. Newton's law works for most everyday cases: baseballs, satellites, even missions to Mars. Einstein's theory is needed for extreme gravity, high speeds, or precise measurements. It explains black holes, gravitational waves, and Mercury's odd orbit. Think of Newton's gravity as a simple map, great for daily use. Einstein's is a detailed GPS, essential for the most challenging journeys. Einstein's theory includes Newton's as a special case. Newton wasn't wrong. Einstein just expanded the picture. Science builds on itself, making our understanding deeper and more complete. Gravity's story is one of discovery and refinement. Even with Einstein's theory, science never stops testing gravity. We know our picture of the universe isn't complete. Big mysteries remain. One challenge is uniting gravity with quantum mechanics, the science of the very small. The rules of quantum mechanics and general relativity don't fit together, especially in extreme places like black holes. Scientists search for a deeper theory, quantum gravity. To find it, we push Einstein's theory to its limits, looking for tiny deviations. We study gravitational waves, the cosmic microwave background, and the motion of galaxies. Dark matter and dark energy are mysteries that might reveal new physics or gaps in our understanding of gravity. Galaxies spin faster than they should. Maybe there's invisible matter, or maybe gravity works differently on cosmic scales. By testing gravity, we hope to answer these cosmic questions. The quest continues. Gravity may still have secrets to reveal. Science is always reaching for the next discovery. Gravity is the architect of our universe and the silent partner in our daily lives. Without gravity, there'd be no Earth, no sun, no atmosphere, no life. Gravity forged the atoms in our bodies inside stars and holds our world together. It keeps our atmosphere in place, lets water cycle, and gives us a sense of up and down. Plants grow roots, we walk upright, and life thrives, all thanks to gravity. Our understanding of gravity powers technology, satellites, GPS, and space exploration. Even your phone's GPS needs Einstein's theory to work accurately. Every falling object, every orbit, is gravity in action. Gravity is more than a rule. It's the cosmic glue holding everything together. It shaped our past, governs our present, and holds the key to the universe's mysteries. From Newton's apple to Einstein's space-time, gravity's story is our story of curiosity and discovery. The adventure to understand gravity continues, and that's a story worth celebrating.